Don't worry, let me teach you. Let's talk about partial derivatives. These are used for multivariable functions, but in this case, we're going to take a look at a 3D function. Okay, so it's f of xy, meaning at every xy coordinate, okay, there's a z value. Now, just to intuitively kind of explain what partial derivatives really are, take a look at this. So imagine I'm standing over here, okay? Now, in my surface here, my partial derivative of f with respect to x is how much the x changes, or it's the rate of change of x while keeping my y constant. So while I'm moving exactly in the x direction, I kind of observe that, oh, the slope here is kind of going a little bit down, right, in the x direction. So this is my rate of change with respect to x, okay? And now, similarly, if I walk in the y direction, I can observe that, hey, this slope looks a little steeper. So this is my partial derivative with respect to y, okay? So that's basically what it is. It's the rate of change of x, for example, while keeping y constant, and it's the rate of change of y, for example, while keeping x constant. Now, the basic principle in evaluating a partial derivative is you just take the derivative of f with respect to a variable, but you keep the other variables constant. So for example, in my function f, if I take the partial with respect to x, then I take the derivative with respect to x only, but I keep all other variables, like for example, y, constant. So let's do an example. Okay, first example, we do fxy is equal to x cubed y plus 4x plus 3y. Okay, so let's start out with an easy example. Here, I want to take the partial derivative with respect to x. So x will be my variable. Okay, so in my first term, I see that it's just a constant multiplied by this x cubed. So I use power rule. So that's 3x squared multiplied by the constant. So if you can kind of visualize it, let's say y is like the constant 2, for example. So if this was 2x cubed, then your answer would be 6x squared, right? That's the derivative of 2x cubed. And so it's basically the same as this. You're just treating y as a constant, okay? Now we move on to the second term, okay? 4x. So what's the derivative of 4x? That's just 4. And now plus 3y. So this thing is just a constant. And you know that the derivative of any constant is just 0. So that's plus 0. So this ultimately equals to 3yx squared plus 4. And that's your partial derivative with respect to x. Okay, just so you know what I mean, let's try doing it with respect to y. So what's the partial of f with respect to y? Here, our variable of interest is y. Okay, so let's try it out. Now, our first term is a constant multiplied by y. So the derivative of that is just the constant, right? It's kind of like saying what's the derivative of 5y with respect to y? That would just be 5, right? It's the same basic principle, and we're just applying it. Now we add this to the next term, 4x. So what's the derivative of 4x? I'll give you a hint. It's either 4 or 0. And in this case, it's actually 0 because x is kept constant when we take the partial derivative with respect to y. Okay? And finally, we have plus 3y. So again, this would just be taking the derivative normally, and that is 3. So your final answer for partial f with respect to y is equal to x cubed plus 3. So as you can see, our answer here was different than when I did the partial with respect to x. Again, the slope in this function is different when I go in the x direction, and the slope is different when I go in the y direction. Okay, just to solidify understanding, let's try doing an intermediate example. Okay, so this is fxy is equal to x squared y plus sine x multiplied by e to the xy. So in this case, we're going to take the partial derivative with respect to x. So again, this term is just simply power rule. So that's 2xy. Again, y is a constant. Okay, now this term is a bit trickier. So we see that there are two functions over here, our trig function, sine x, and our exponential function, e to the xy. Okay, so we can do product rule because both of these functions have our variable of interest, which is x. Okay, so let's do the derivative of the first function, this thing. So the derivative of sine x is cosine x. Multiply that with whatever the second thing is. Okay, now we add, okay, just copy down the first thing. And now we multiply that by the derivative of the second thing. So that's e to the xy, since the derivative of an exponential function is just itself, but we get chain rule. So we actually need to take the derivative of this xy over here. And with respect to x, the derivative of xy is simply y. And so this now is our final answer. Hopefully, you kind of understand partial derivatives a bit better. Just remember intuitively that it's the rate of change in whatever this direction is.